Finding polynomial functions, section 3.4. Example 1, find a polynomial function with least degree that has integer coefficients and x-intercepts 1/2, -3, and 2. Step 1, we want to solve for 0. We wrote the three x-intercepts here: x equal 1/2, x equal -3, x equal 2. So to get rid of the denominator, I can multiply both sides of the first equation by 2. And 2 times 1/2 is 1, so it'll give us 2x is equal to 1. And then we want to subtract 1 for both sides of the equal sign, and that gives us 2x minus 1 equals 0. The second equation, if we add 3 to both sides of the equal sign, we'll get a 0 on the right side, and that'll give us x plus 3 equals 0. Minus 3 plus 3 is 0. The third equation, subtract 2 from both sides of the equal sign, and we'll get x minus 2 is equal to 0. Okay, so those are 3 equations, and when at the x-intercepts, either 2x minus 1 equals 0, or 2x plus 3 equals 0, or x minus 2 equals 0. Okay, so that means the product has to equal 0. So that means the quantity 2x minus 1 times the quantity x plus 3 times the quantity x minus 2 is equal to 0. And that means our function is going to be f of x is equal to 2x minus 1 times the quantity x plus 3 times the quantity x minus 2. Okay, so we can expand that and simplify a little bit. So we can use the FOIL method here to expand these. So it's first times first, 2x times x is 2x squared, and then the outer 2x times 3 is plus 6x, and then the inner product minus 1 times x minus 1x, and last times last is minus 3. Okay. Okay, so we can combine the two x terms. 6x minus 1x is 5x. So that's going to give us 2x squared plus 5x minus 3 times the quantity x minus 2. Okay, so then we can so I multiply the first two factors, and so we still have to multiply by x minus 2, the last factor, and we can distribute the x to all three terms and distribute the minus 2 to all three terms. So it's 2x squared times x is 2x to the third power. 2x squared times actually, let's do this one next. 5x times x will be plus 5x squared, and then minus 3 times x is minus 3x. And then we want to distribute the negative 2, multiply each term by negative 2. So 2x squared times negative 2 will be negative 4x squared. 5x times negative 2 is negative 10x, and negative 3 times negative 2 is plus 6. And then we can combine like terms. We only have one x cubed term, we bring that down. 5x squared minus 4x squared would be 1x squared, or we just write x squared. Minus 3x plus negative 10x is negative 13x, and copy the plus 6. So our polynomial is 2x cubed plus x squared minus 13x plus 6. And just a comment here, there's actually more than one solution to this problem. For any number a, any polynomial of the form f of x equal a times the quantity 2x cubed plus x squared minus 13x plus 6 will also have the same x-intercepts. But usually, unless there's additional constraints, it's usually convenient to take a equal to 1. So that will give us the the solution that we had here if we take a equal to 1. So anyway, that's so our answer is 2x cubed plus x squared minus 13x plus 6. Okay, example 2. Find a polynomial function with least degree that has integral coefficients and intercepts x equal a half, x equal -3, x equal 12, and x equal 2 rather, and y equal 12. The first step, the x-intercepts are the same as the previous example. So for some number a, f of x is going to be in the form a times the quantity 2x cubed plus x squared minus 13x plus 6. The other piece of information that we have, in addition to x-intercepts, we have a y-intercept of 12. So at the y-intercept, x is going to be 0. So that means that for the polynomial that we want, f of 0 has to equal 12. If we plug in 0 here, replace x by 0, we'll get a times the quantity 2 times 0 cubed plus 0 squared minus 13 times 0 plus 6, and that has to equal 12. And we're going to solve this for a. So these first three terms are all equal to 0. That 0 cubed is 0, 0 times 2 is 0, 0 plus anything is 0, 0 plus, I mean 0 is 0. But, so that leaves us with 0 plus 6. So we're going to have a times 6, or just 6a, is equal to 12, and divide both sides by 6. And that means that a is equal to 2. Okay, so then we can replace a by 2. F of x is 2 times the quantity 2x cubed plus x squared minus 13x plus 6, and we can distribute the 2, multiply 2 by each term here, and that'll give us 4x cubed plus 2x squared minus 26x plus 12. Okay. So that's our polynomial. Okay. Third example. Find a polynomial function with least degree with integer coefficients with the property that f of x approaches negative infinity as x approaches positive infinity, and with x-intercepts 1/2, -3, and 2. So again, these are the same x-intercepts as the previous example. So that means that for some number a, f of x is a times the quantity 2x cubed plus x squared minus 13x plus 6. And the second step, because the function approaches minus infinity when x is large, the leading coefficient must be negative. So that means that a must be negative. Since there's no other constraints, for convenience, we'll take a equal -1. But we could let a equal any negative number. Okay, so f of x is -1 times the quantity 2x cubed plus x squared minus 13x plus 6. Distribute the -1, we'll get -2x cubed minus x squared plus 13x minus 6. And that's our function. Okay, example 4. Find a polynomial function with least degree with integer coefficients and x-intercepts x equal 1 with multiplicity 2 and x equal -1 with multiplicity 1. Okay, so that multiplicity 2 means that that factor has to occur twice. So we want to write the equation x equal 1 twice. So we want to solve x equal 1, x equal 1, and x equals -1. This the first equation I wrote twice because the multiplicity is 2. And we want to solve these for 0. So the first two equations, we want to add -1 to both sides with the equal sign, and we'll get x minus 1 equals 0. And the last equation, we'll add positive 1 to both sides of the equal sign and get x plus 1 equals 0. And then, so at the x-intercepts, one of these equations has to be 0. And so that means the product is going to be 0. x minus 1 times x minus 1 times the quantity x plus 1 is 0. So our function, we can write that as f of x equal to quantity x minus 1 times x minus 1 times x plus 1. Okay, and then we can expand that and simplify. So, okay, so if we use the FOIL method for the first two factors, x times x is x squared. The outer product is negative 1x. Inner product is negative 1x. Last times last, negative 1 times negative 1 is plus 1. And we can combine the two x terms. Negative 1x plus negative 1x is negative 2x. So we have the quantity x squared minus 2x plus 1 times the quantity x plus 1. And then we can distribute again. So we want to multiply each of these terms by x. So it's x squared times x is x cubed. 2x times x is minus 2x squared. 1 times x is 1x. And then multiply each of these terms by 1. So 1 times x squared is plus 1x squared. 1 times minus 2x is minus 2x. 1 times 1 is 1. Okay, so then if we combine like terms, we'll have x cubed minus 1x squared, which you don't really need to write the 1, minus x squared, be minus 1x, or just minus x, and then plus 1. So our function is f of x equal x cubed minus x squared minus x plus 1. And again, for any number a, the polynomial of the form f of x equal a times the quantity x cubed minus x squared minus x plus 1 will have the same x-intercepts with the same multiplicities. So unless there's additional constraints, such as a particular y-intercept, it's usually convenient to take a equal 1. But again, there could be more than one answer. And so anyway, our final answer, f of x equal x cubed minus x squared minus x plus 1. And that concludes this presentation.